this evening. I was delighted when Felix, who is a member of the REC, approached me and said, I think we could come up with a really good idea for a lecture when he attended one of our previous ones, on the back of which we have this event this evening. So a very warm welcome to both Felix on behalf of Ocean Ambassadors and to our star here, Ffion, who's going to take us through some of her passions about the work she's doing at the moment, what she's been studying. Shall we welcome them in the usual way?
What do you do when the largest ocean in the world threatens to stop global ocean circulation? Intrigued, worried, perhaps you could learn from it. Actually, the correct answer is, can I come to an Ocean Ambassadors lecture? Now I've got you here, I'd like to genuinely welcome each and every one of you. And I mean that sincerely, because every single one of you tonight has something to offer, has something to contribute to this new world of oceans. You may not realize it, but the more diverse your interests, the more expertise you have, the more crazy your ideas, the better. I'd like to say this, that we're not here to lecture people, we're here to open doors. And we're here to open doors to ideas. The whole ethos of Ocean Ambassadors is to talk particularly to students, because they are full of ideas, but they may not know how to open doors, they may not realize how to go about it, and we would love to help them. And mainly through lectures by scientists coming to talk to them. We had one recently by the world's deepest ocean explorer, Jonathan Copley, who took us from Portugal to Puerto Rico under the ocean, under the Atlantic. It was quite amazing, and the creatures involved. Now, each one of you might meet somebody else who sparks an idea. So, give you an example. We are mainly trying to create noise exclusion zones in various areas. So we'll let the noise expert, we have one here tonight, meet the ornithologist who knows how owls fly silently throughout the night, and the inventor, and the shipbuilder. The shipbuilder wants to have an outlet. He wants to tick the corporate box. He wants to be new on the block when these restrictions come in, which they are already coming in particularly in Scandinavia, I believe. So, this meeting of these people, what does it produce? A silent propeller, for example, a silent propeller. And that helps the world's oceans, the whales and the creatures to transmit their sounds for hundreds of miles. A whale was recorded transmitting to another whale, looking for a mate perhaps, 500 miles. Tonight, though, is special because we're changing the roles. Instead of scientists lecturing to you, we have the student lecturing to us, although she is a scientist as well, but she's still a student, an enthusiastic one. So recently we lectured to 360 students at Atlantic College, where I was, where we did sea rescue. And those 360 students were aged about 16 to 20 years old, from 90 different countries. They all were enthusiastic. They all will go back and open doors and be world ambassadors for this wonderful planet we're on. We're going to extend to other countries. We have a great friend here from Western Australia who may do the same and create a hub like we have tonight. So we will spark new ideas. Let me just introduce myself. I'm Felix Appelbe. I founded Ocean Ambassadors. I was at Atlantic College, now United World Colleges, where we have 17 colleges throughout the world, and this will spread. I'd like to introduce Ffion Mitchell, who also was with the RNLI and helped rescue people at sea. So without more ado, the ocean is in her hands.
No pressure.
Let's join her passion and enjoy ourselves. Oh, by the way, questions after the talk.
Yes, thank you. Well, thank you, Felix, for such a lovely introduction. And I'd like to extend a warm welcome to you all, and I'm really overwhelmed with the turnout, and I'm really thrilled that I'll be able to share with you my learnings and my passion for Antarctica and the Southern Ocean. So firstly, just a bit about my background. So for those of you who I haven't had the pleasure of meeting yet, my name is Ffion Mitchell, and I completed my International Baccalaureate at UWC Atlantic College in South Wales, which is how me and Felix met through our alumni network. I then went on to complete a BSc in Geography at the University of Exeter's Cornwall campus, and you can currently find me at the University of Plymouth completing a Master's in Applied Marine Science. But enough about me. Let's talk about why we're really here, and that's to learn more about Antarctica and the Southern Ocean. Now, if I were to attempt to thoroughly go through the continent in fine detail, I would be here standing and talking to you all for days. So in order to condense such a broad topic, I plan to move the following key themes with you. So firstly, a brief history, exploring Antarctica's early speculation and explorations. And then the environment, summarizing Antarctica's extreme yet highly rich climate. Introducing some of the key peculiar and wonderful Antarctic communities. I'll then highlight the Antarctic Treaty as an integral piece of legislation that acts as conserving the continent. I'll give you some examples of current world-leading research that's coming straight from the continent. And then I'll conclude the talk through summarizing some of the most key threats that the continent faces, as well as the solutions. So small actions that both you and I can take as individuals to help protect such a precious place. So to start the talk, I wanted to open up with a question. And it's perhaps quite a difficult question, but does anyone know who this individual is? Yes? No. Good guess. Keep going. Any ideas? Yeah? Yes? Jeremy Corbett. Yeah, I can see the likeness. So this, in fact, is Aristotle. And in the 4th century BCE, he famously speculated that there must be a region bearing the same relation to the southern pole as our region bears to our pole. And he termed this conceptualized landmass Antarcticos, which was the direct opposite of Arctos, the northern constellation found above the North Pole. Now, as a geographer myself, I have a particular soft spot for cartography and believe that one of the best ways to demonstrate the uncovering of Antarctica is through the evolution of maps. So this was a recreation of Pomponius Mela's map from the 1st century. And as a Roman cartographer by trade, Pomponius Mela believed in the later speculations of Aristotle, but also speculated that there was a torrid zone that surrounded the continent, hence why it had never been breached by previous explorers. And in the 2nd century, this is Ptolemy's map. Ptolemy further speculated on the size of the southern landmass, focusing on its sheer extent down in the south, a dominant geographical feature so large in size required to balance out the land masses that we knew of in the north. So let's fast forward now to the 16th century. Now, this is a particular interesting map because it was created by a Turkish admiral called Piri Reis. And he used a combination of his Ottoman military intelligence and private documents from the Library of Constantinople to formulate a map of Antarctica that was completely ice-free. And even today, it is still a mystery how he was able to encapsulate such an accurate depiction of Antarctica's topography without the ice caps. Despite these portrayals of Antarctica, however, highly reinforced by the logic of the time, they were all in for a surprise following the expedition of this man here. Does anyone know who this is? Cook, absolutely. So Sir James Cook in the 18th century was the first man to circumnavigate the entirety of the Antarctic continent. And he proved that the landmass was indeed a lot smaller than originally anticipated. While Cook and his companions failed to reach the continent itself, it was the first expedition to breach what we call the torrid zone. Despite such an achievement, however, Cook was not a fan at all of this newly discovered territory, reflecting in his diary, "I, who had an ambition to go as far as possible for man to go, was not sorry in meeting this interruption," referring to the vast sea ice that prevented him and his expedition team reaching the continent. His expedition was further successful, however, by the work of one rather understated individual, William Hodges. And he was responsible for producing this masterpiece. This painting of Antarctica encapsulated the first eyewitness account of the continent. It's pretty spectacular, isn't it? And at last, the world was provided with real visual evidence of the existence of Antarctica. And so it came as no surprise that following the circulation of the news, Cook's expedition sparked a race to reach the South Pole. Now, one of the most first and famous attempts was made by this individual here, and his name is Ernest Shackleton. He was an Irish explorer who attempted to reach the South Pole in 1908. He became the first man to reach as close as he did, indicating by his endpoint here. And as you can see, it wasn't so far from the South Pole at all. However, his transport methods that he selected proved highly inadequate, consisting of a very small number of ponies and a motor car. So sadly, he was forced to turn around and make his way back to his ship. The first expedition to successfully reach the South Pole was led by this gentleman here. And he is a Norwegian explorer called Roald Amundsen. And he reached the pole in 1911, and you can see the route that he took here. He was well experienced with harsh polar climates, and Amundsen was therefore very suitably equipped with dogs, sledges, and fur clothing for warmth. His practical and logical planning is what allowed him to succeed in being the first to reach what we call the Southern Pole. Although, of course, Amundsen wasn't alone in his race in 1911. And for 99 days, he was head-to-head with this gentleman here, Sir Robert Falcon Scott, a British explorer and his team. However, after 99 days of being head-to-head, it's okay. Scott's team were very much less prepared for the harsh environmental obstacles that they faced. Therefore, they arrived a painful 3 weeks after Amundsen had already arrived. Unfortunately, upon their return, Sir Robert Falcon Scott and his 4 men in that smaller expedition team perished, frozen in their sleeping bags. Their bodies were later discovered by this biologist, Cherry Gerard, and his 2 biology companions. Although these 3 gentlemen here were not interested in making their way to the Southern Pole, but rather to trek to a place called Cape Crozier to collect these objects here. And does anyone want to hazard a guess at what these objects are? Exactly, penguin eggs. Yeah, so these are emperor penguin eggs. So Cherry Gerard actually recalled upon his return, once he'd safely stored the shells upon their expedition and back across the seas back to Britain, his bitter disappointment in discovering, in fact, that the shells themselves had revealed very little science behind penguin embryology and to science as a whole. So imagine. Despite a lack of groundbreaking biological discovery, however, they did discover one key thing, which was that they'd found the windiest place on Earth. So these are actually some original photos taken from their expedition. Cape Denison, which is now a prominent research station out in Antarctica, experiences an average wind speed of 75 miles per hour, with gusts of over 112 miles per hour incredibly common. But how is Antarctica so extremely windy? Well, our answer actually lies in the Earth's atmospheric system. Now, I know this could easily go over your head, so I'm going to try and simplify it as much as possible for all of you. So, just for some basic global context, our atmospheric circulation determines both our weather and our climates. And it does this by circulating air through various cells that you can see here. Just for this instance, though, we're going to focus on our polar cell here and the southern pole. So the polar cell receives air that is drastically cooled since traveling southwards from the equator. Colder air is denser and so sinks to areas of creating a high pressure system. Winds flow from areas of high pressure to areas of low pressure along what we call a pressure density gradient. For example, say you were in a pretty busy room, like we are this evening, and you wanted to make your way into a more emptier space. It's a really similar concept. You'd be moving from an area of high density, high dense space to an area of low density, less dense space. The larger the pressure gradient is, the stronger the winds are. So as you might notice here, this black arrow at the bottom, the airflow is also moving in a leftwards motion. And you can see what this looks like across the continent here, indicated by these blue lines, some of those green arrows moving off left. And this counterclockwise motion is due to the Coriolis effect, which is a force that responds to the Earth's rotation. As the wind moves outwards, away from the continent, it is deflected left. So, as well as this atmospheric system, Antarctica's shape has a very significant role to play. It's the highest elevated continent in the world, with an average elevation of 2,500 meters. So consequently, as air descends down the continent like this, it picks up a tremendous amount of speed before reaching the coastline. And these are what we call katabatic winds. They're driven by a combination of both the pressure gradient force, mentioned just now, and gravitational force. And they play a principal role in the formation of these features here, polynyas, which is essentially this little space here between the ice shelf and the sea ice. Now, these features are very important as they are key in the formation of Antarctica's deep bottom waters, but I'm going to go into that in more detail later on. So, as well as being the windiest place on Earth, it's also the driest place on Earth as well. And in this instance, the Sahara Desert can actually take a back seat because Antarctica is the largest desert in the world, nearly triple the size of Australia during winters. Descending cold air has a lower capacity to retain water vapor, which explains why Antarctica's continent receives an annual precipitation of less than 50 millimeters. It's also subjected to continentality. Most of its terrain is very far from the sea, and so it doesn't benefit from that additional moisture one often gains from the oceans. So these are some computerized models that I took from a research paper that was published last year by Tang et al., indicated down here. And what they were working on was modeling the past historical precipitation trends experienced in the continent. Now, while you can clearly see each model has a slightly different output, it's really important to note that all the models have a mostly general agreement that the continent experiences very little to almost a decline in precipitation over the period in which they were conducting their study, which was about 1979 to 2005. So at this point you must be thinking, well, if there's such little precipitation, how is there so much ice? And it's a really, really good question to ask. And in fact, the answer is quite simple. So of what little precipitation does fall, it freezes instantly. And as the continent has been around for thousands and thousands of years, the ice that we see here today basically represents a mass accumulation of ice that's been occurring over a very, very long time scale. So of course, saving perhaps the most obvious characteristic till last, it's also the coldest place on Earth. So Antarctica receives a mean summer average temperature of about negative 28 degrees Celsius and winter temperatures of about negative 58, which means that Antarctica isn't perhaps the most ideal summer holiday vacation location for most. Temperatures as low as even negative 89 degrees have also been recorded. The continent's coldness is mostly as a consequence of its distance between the poles and the sun and its indirect contact. This means that it receives less direct solar radiation than other parts of the Earth, which you can see here. So most heat is absorbed at the equator, with heat actually being lost at both of the poles. And this heat loss is also aided by Antarctica's strikingly white color, which you can see here. It's very, very noticeable from space, but what's important to consider is that the sheer blinding whiteness of the continent acts as a reflector. So the solar radiation that's reaching the continent is actually more likely to be reflected than to be absorbed as a consequence of this. But how is it colder than the Arctic? Sure, they're both poles. They're both reflecting a lot of heat and not really absorbing it. So how is it colder? Does anyone have any ideas? I'll be really impressed. Yeah.
It's more windy.
Yeah, it's more windy. That is a fact, but that's not particularly why it's colder. Anyone else?
It's the way it comes up, like that always under the far away from.
Yeah, so always that indirect contact. Yeah, well, the Arctic actually receives the same amount of indirect contact.
Less water.
Less water. Kind of right, Felix. So the answer actually lies in its geography. So Antarctica is a continent surrounded by ice and ocean, whereas the Arctic is ocean surrounded by land. Now, the water under the Arctic ice is still cold. However, it's still warmer than the ice above it, and so naturally has that warming effect. Antarctica, however, consists of ice sheets and ice shelves that are bounded by land and therefore are not as subjected to the warming effects of the ocean currents at the centers of the continent. its elevation naturally also makes it much, much colder. But of course, Antarctica is not only extreme on land, but equally under the surface of what we call the Southern Ocean. So the Southern Ocean is the 4th largest ocean in the world, although arguably the most important both climatically and ecologically. The boundaries of the SO lie 60 degrees south, about roughly indicated here, and is the only ocean in the world that is joined by all other major oceans. So that's the Indian, the Pacific, and the Atlantic. Sea temperatures rest at just above freezing point, from about -2 to 10 degrees. And it's also a mostly deep ocean, with depths averaging 13 to 16,000 feet. So with such a large, deep ocean, coupled with the strongest winds in the world, it might not be surprising that Antarctica also hosts the roughest seas imaginable. And to illustrate this, I have a little video for you all. So if you just give me a second, I'm going to put that up. Thank you. Oh, I hope he wasn't caught in this.
I looked at my house last sector.
So I really hope that hasn't completely put you off visiting. I promise that was just a storm. So those aren't the normal situations, but it's always good to be prepared for the worst, as I like to say. So a key feature in the Southern Ocean that drives such conditions as the one that you just saw is the Antarctic Circumpolar Current, or as historically deemed, the torrid zone. Now this current is completely unique, as it's the only oceanic current in the world that formulates a complete circle around a continent. And as a consequence of that, it does some pretty miraculous things.
Because the wind going the other way.
Yes, yeah, that's a very good observation. So it creates an almost isolating system. It surrounds the continent, limiting the extent to which the warmer external waters from those joining larger oceans can actually penetrate that boundary into the icy waters of the Southern Ocean itself. It's also the largest current in the world. So it's a current that extends from the surface to depths of about 2,000 to 4,000 meters and can extend as wide as 2,000 kilometers. Now, as the largest current in the world, it's also key in transporting large amounts of water and therefore plays a key role in the global oceanic transportation of heat, fresh water, nutrients, and gases such as the carbon dioxide. So I guess the next big question is, we have this really, really big, really important current that is key for global transportation and can also be very dangerous, as you have experienced. So how do we know where it is? How are we able to predict its location as well as its boundaries? So we define the boundaries through strong variational fronts. And they are found and located through the analysis of specific water properties. And these are temperature, salinity, and density. The ACC is associated with 3 major fronts, 2 of which are indicated here. So you can see the outer subantarctic front, and then the more middle polar front, And then there's also another front that you can't quite see around here, which is called the Southern ACC Front, otherwise known as the Antarctic Divergence. So these zones formulate as a consequence of some pretty incredible topography that unfortunately I don't have some images to show you of. I'm sorry, but I can try to point them out here for you. So one key area of topography is this section here. And as you can see in comparison to the rest of the continent, it's rather narrow, and this forms an almost funnel-like system. And it's between the West Antarctic ice sheet, the northern tip, and also the southern tip of South America. It's also subjected to various ridges and plateaus that surround the continent that act to channel that current so that it maintains its circular motion. And it also has a cocktail of water masses, which is pretty fantastic. So as it is the key meeting point for all of these large oceans, a lot goes on under the surface in terms of its mixing. And the Atlantic circumpolar current is key in mixing these waters and then transporting them back out into the wider oceanic system. So for example, you have the North Atlantic deep water that moves in from the Atlantic. It then begins to mix, and that formulates the Antarctic surface water. And this is at the closest front to the continent, which is the Antarctic divergence, indicated here. The Antarctic surface water then moves northwards until it reaches the polar front, whereby it meets the subantarctic surface water, mixes and sinks just below the surface to formulate the Antarctic intermediate water. Antarctic intermediate water is then transported northwards still and sinks down into the deep basins of the Pacific, Indian, and Atlantic waters and is transported across the globe. It is this water system that plays a very key role in nutrient transportation for other marine species across the globe. So it's a very, very active hydrographic system, but that's not all. Let's not forget one of our most important water masses, homemade, if you like, the Antarctic bottom water. And they are formulated as a consequence of this feature. Does anyone remember what it's called? It begins with a P, if that helps. Close, close, yeah? Anyone else? Don't be afraid. So these features are called polynyas, and they formulate as a consequence of those katabatic winds that I previously mentioned. And what happens is those katabatic winds rush down the continent and force this open surface layer of water. Now we know that sea ice is fresh, and so what the sea ice does during its period of formation is that it rejects the salt into these surface layers. This is under a process of what we call brine rejection. So as you can see here, in our little space that we have between the ice shelf and the sea ice forming, we have the polynya, and we have that extra salty water, which is the densest water in the world, I might add, sink down to form cold, salty shelf water. This then continues to sink down the continent into the very deepest depths of the oceanic basin. Now, another reason as to why this water mass in particular is so important is because it acts as a ventilator for the larger oceanic basins across the world. So during its time resting at the surface, it traps a large amount of oxygen. So what it's doing, it's bringing large amounts of oxygen down from oxygen-rich surface waters to previously oxygen-deprived deep waters. And it is the combination of those nutrients and those oxygens that's being drawn down to the deeper waters that allows for life to thrive there. So who calls the Southern Ocean home? I think a lot of people have this perception that Antarctica is a very wild and a very vicious environment to live in. But it's actually as a consequence of these nutrient-rich and oxygen-rich water masses that allow for life to thrive. So we have the peculiar. It's quite strange looking, isn't it? So this is the Antarctic sea pig. And it's a type of sea cucumber, actually, and spends most of its time trawling around along the seabed. And just for a size reference, it fits just about in the palm of your hand. We also have the majestic, the humpback whale. Has anyone in this room ever seen a humpback whale in real life? You have? Oh, no, so many of you. I'm so jealous. I've never seen one. It's on my bucket list. So humpback whales are, in fact, the most common species under the baleen whale in Antarctic waters. And you find a lot of them around Antarctica, and that's because their main food source, the Antarctic krill, is in great abundance. We also have the jokers, the emperor penguins. So this is what happened when some emperor penguins came across a camera from the Australian research team. So emperor penguins are, in fact, the largest of all 18 penguin species that you can find on Antarctica. And they're the only mammal to breed and lay their eggs in the harsh winter experienced on the continent. So we also have their predators as well, the leopard seal. Now, these large mammals often spend their time waiting and loitering around under the sea ice, expecting penguins to dive down on their daily fish, and then they snap them up, which is pretty terrifying. And I can only imagine how this photographer felt in the water, observing that happening right in front of him. I don't think I'd have the confidence, to be quite honest with you. So what I'm trying to get across is Antarctica is teeming with life, ranging from predatory mammals to beautiful, colourful species that you can find on the sea floor. And this is because they're all there reaping the rewards of these oxygen and nutrient-rich cocktail of water masses. And I just couldn't resist putting a picture of this lovely little species up. Do we have any divers in the room this evening? Yeah, does anyone know? Yeah, nudibranchs. So this is actually Antarctica's own species of nudibranch, and it's just called the yellow nudibranch, which is pretty self-explanatory. But for those of you who don't know what a nudibranch is, it's essentially a sea slug. But I always find that such an understated title because they're just my favourite sea creatures. They're so cute, aren't they? So hopefully you're all now able to paint a picture of how wonderfully diverse Antarctica is in terms of its biology. But how do they all manage to live in peace despite our not so pleasant nature as a human race to exploit? Well, they're in fact protected under the Antarctic Treaty. And the Antarctic Treaty came into force in 1961, stemming from growing tensions that arose between the 12 original states, if you like, that were involved in those early exploratory periods. To avoid conflict, these 12 signatories of the treaty agreed upon a peaceful truce for the advancement of both science and international cooperation. And to this day, it is the only piece of international legislation of its type. So I've just indicated here some real key articles that stem from the treaty. So we have Article 1, Antarctica shall be used for peaceful purposes only. And Article 2, freedom of scientific investigation and cooperation. Article number 3, the free exchange of scientific observations and results, which was quite a big one for a lot of them. And then we have no acts or activities were able to take place that would constitute a basis for a claim to territorial sovereignty. And one that's quite interesting that a lot of people don't really think about when they think of the Antarctic Treaty is that stations, installations, and equipment are open at all times for investigation. Which means that, for example, if you were based at a research station in Antarctica, you could be woken up at 3 a.m. by an Australian representative that wants to check out your recycling. It's honestly that sporadic. So 30 years later, the treaty actually entered into the Protocol on Environmental Protection in 1991. And this classified Antarctica as a nature reserve and has prohibited any activity relating to its mineral resources, so deep sea mining essentially. It also demands thorough environmental assessments to be made on all activities, in particular tourism. The International Association of Antarctica Tour Operators, bit of a mouthful, so IATO for short, is a member organisation, and it has set the global precedent for the best practice regulation in this region for tourism. A lot of people don't consider Antarctica to be perhaps a very popular tourist destination, but it already receives over 30,000 visitors per summer, which is a lot. So why are they there? Why are scientists there anyway? Well, they're there because Antarctica is an ideal place to do research on a vast array of various topics. And I've just put some up here just as a little example. So we have microplastics research, sea level rise projections, paleoecology, biochemistry, volcanology. And this really interesting study here that, again, I feel would be of particular interest to any divers in the room or people that like to snorkel. Because what this paper indicates here is that there is an absence of wood colonizing microbes and organisms, which seems to indicate that the wood is actually preserved much better than the oceans that we visit regularly as divers and snorkelers, meaning that the chances of finding shipwrecks in complete pristine condition at the bottom of Antarctica's waters are incredibly high. But this is just essentially the start of something that I hope will uncover those wonderful shipwrecks. So those are some interesting areas of current research, but the original research taking part on Antarctica, if you like, were the collection of these. And does anyone know what they are? Ice cores, great. I think I was like half the room, well done. That's good. Yeah, so ice cores. Now ice cores are really important because how they were obtained was by drilling deep through the ice sheets. But Antarctica has the longest and the oldest record in the world. So from these ice cores, the longest can be drilled up to 3 kilometers in length, and they account for 800,000 years of data from the past climate. So how they do this and how does it work? So what the ice does, each layer, if you go back to what I was mentioning earlier about that mass accumulation, each layer is trapping bubbles, and those bubbles act as a sample of the atmosphere at the time. Thus, we can deduce the atmospheric composition of that time by examining what's in the bubbles, essentially. It's Antarctica's ice core data that has acted as key information that we use today to prove anthropogenically forced climate change. It's also key in predicting our future as well. So the information that they collate from here is used to validate computerized models, similar ones to the models that I showed you earlier. So before scientists are able to simulate the future, they need to know that their simulations are going to be accurate. So how they do that is they use these simulations to project back in the past, and they use the ice core data as indicators of whether they are right or not. But it's not all about the ice core data, of course. Scientists in Antarctica are incredibly active in applying a range of methods. And a key method for collecting data is, in fact, diving. So divers such as the ones that you can see here, will dive down to the shallowest areas of the seabed, and they will be tracking things like sedimentation. And they'll be doing this through the use of sediment traps, which are essentially these little pots that they'll dive down and take a core sample out of. And what this allows them to do, they're able to determine organic deposition, and they're also able to identify benthic species. So benthic species are essentially the species biota that are living on the surface of the seabed and also in the upper surface layers as well. Divers are also really important in the sense that they make a lot of observations of feeding habits, species behaviours, and also their growth rates as well. And in some instances, these species are extracted for further lab analyses. But aside from biological methods, scientists are also recording really important physical data and information using this instrument here. Now, this instrument is what we call a CTD rosette. And this CTD rosette is essentially distributed down from a ship through the depths of the water column. And as it descends, it's taking temperature, salinity, and density readings, as well as taking water samples. Now, if you remember, it's those properties that's really, really important for us to detect, because it means that we're able to trace and to track the movement of those fronts that are really important for our water masses. So over time, we're able to see how they change, whether they're strengthening or weakening, and how their movements are occurring across both temporal and spatial scales. And unfortunately, through these physical readings, they are coming out with some pretty alarming realities. So firstly, the ocean heat content is rising, which means that the oceans are warming. And since 2006, an estimated 60 to 90% of this global oceanic heat content was coming directly from the Southern Ocean. You can see this particularly here, but we also have large amounts of oceanic warming up here as well in the Atlantic. But not only is it getting warmer, but it's getting fresher as well. This particularly affects our really valuable Antarctic bottom water. So, as you can see here, you have these temperatures increasing at the surfaces, but also beginning to increase at those depths as well of about 2,000 meters. It's also becoming fresher as well, indicated by these blue areas. And as these fresh waters circulate, that fresher water will reach all depths of the Southern Ocean. So, freshening is taking place particularly as a consequence of glacial melt. Now, what's important to realize in terms of melting that's happening in Antarctica is that what's happening in the west is very different to what's happening in the east. And a lot of people have this misconception that the whole of Antarctica is melting all at exactly the same rate, and it's quite frankly not true. So what we're really concerned about is the West Antarctic ice sheet. And we're concerned about it because the whole of this part of the peninsula rests well below sea level in comparison to East Antarctica, therefore exposing it a lot more to those ocean warming currents. We also have its geography to consider as well. So if we're looking at the shape of West Antarctica, it's naturally very thin at particular parts, but it juts out into that Atlantic circumpolar current. So as it warms and as the current rotates around the continent, it comes into a much more direct contact repeatedly to this part of the West Antarctic ice sheet. So you can see here the thickness change between 1994 and 2012. And you can see that there have been significant losses along the Amundsen Sea, as well as in the north as well, around the Larsen ice sheet. However, East Antarctica is a different story. So East Antarctica is more highly elevated, therefore it's more submerged above sea level. And in its northern parts, it's actually seeing a gain of sea ice. Now there's lots of speculation about whether this is going to be a long-term pattern or not. But what a lot of people generally agree upon is that the gain is as a consequence of warmer temperatures producing more precipitation in these areas. And so as more precipitation falls, more ice is freezing in these parts. However, it's not just about the melting and the thinning of the ice sheets, because actually, if we look over here, without Antarctica's vast drainage system, that melt water wouldn't be going anywhere, and it would simply refreeze again. So coinciding well with the fact that the West Antarctic ice sheet is what we're most concerned about, is that it has much more of an intense drainage system. So if you see these red areas here, we have the Ross and the Ron ice shelf drainage systems. We also have the Thwaites and the Pile Island Glacier drainage systems. And the red indicates the surface velocity. So this ice is melting, but it's being draining at such a speed that it's going to formulate these crevasses that allow that draining system to expand deep and further into the continent. I'm quite partial to a humorous political cartoon, so I really hope you enjoy this one as much as I did when I came across it. So the combination of this oceanic warming and glacial melt come together to formulate a threat that we are hopefully all aware of, which is sea level rise. Now, if we were to expect no change in the emission rates that we are going at currently, we would experience a potential sea level rise of 13.6 meters by the year 2500. And that's only the West Antarctic ice sheet. If we were to make drastic changes as a whole human race that resulted in no future net emissions, then we would be limited, but still perhaps quite significant, to 0.20 meters of sea level rise. However, it's important to consider that in perhaps the worst case situation, where all of the ice sheets on Antarctica melted, we'd be looking at a sea level rise of about 57 meters, which, for your reference, is taller than the Leaning Tower of Pisa. So that's a lot of water. So what does this look like? Well, for the UK, if we were to just look at a 1.4 meter sea level rise, this is what would happen. So a lot of our most vulnerable areas naturally will be our coastlines. But also this area here, and I believe we have someone from Nottingham here, don't we? Hi, Izzy. Maybe you want to consider moving, I don't know. We also have the Netherlands as well. Particular focus on the submergence of Amsterdam here and The Hague. So they face quite a significant problem in the near future. Also Venice and its surrounding coastline. I don't know if any of you haven't been to Venice yet, but I would definitely recommend doing it sooner rather than later, particularly as it is sinking under its own weight anyway.
It's just a meter.
1.4 meters, yeah. Yeah, so this doesn't even account for nearly close to that 13.6 meters that we're looking at if we don't change our emission rates. We also have changes in the ecosystem to think about. So all of these threats that we face are stemming from the Antarctic continent, and we are going to be affected by them, but it's also important to think about how they're going to be affected down there on that continent as well. Now, Antarctica has maintained a rather particular situation in that it's had a very stable, specific environment for hundreds of thousands of years. And so a lot of the species in Antarctica are actually endemic. And what this means is that they will only live and they will only survive in that Antarctic environment that they are familiar to, which means that their ability to adapt to the changes that climate change threatens is unknown. So I'm just going to briefly touch upon a couple of these tables that I'm going to show you. And it's of particular interest because this is very current scientific research. It was published by the British Antarctic Survey just last month. And they have essentially calculated and done an ecological risk assessment for the species in Antarctica. And they've essentially considered the survival rates under various future climatic projections. What's important to know here is that you can see that there is quite a lot of green and a little bit of red in this instance and some yellow. So the green actually indicates species that are likely to not just survive, but actually thrive in changing polar seas. So this would include species like starfish and brittle star. And we also have species that will receive moderate to no change in their survival rates. And we also have the species that are likely to be the most threatened and most at risk. Well, I'd like to draw your particular attention to this species here, the Antarctic krill. Now, the Antarctic krill is a keystone species in the entirety of the Antarctic food web. And their being threatened is what causes this. The penguins. So, with a decline in Antarctic krill, we can expect that to indirectly impact penguin rates. But what's also important to consider is that it's not just about krill. Now, can anyone think of another reason why the penguins could be so badly affected by future changes in polar seas? Well, I think I heard someone say it. Yeah? I'll give you a clue. It's not to do with biology. I've stumped you all. Yeah, partially. So the nutrients that's available to them is changing. But also what's changing is their habitat. So penguins need ice. They need sea ice. They need ice because that's where they breed, that's where they rest, and that's where they recover. And that's, of course, where they launch from so that they can hunt. And the decline in sea ice is going to have a huge direct impact on the penguin population across all species, not just the emperor penguin, but also the alderley and the chinstrap as well. So, God, that was a bit doom and gloom, wasn't it? So, there are a lot of alarming realities that we're all being faced with as a consequence of Antarctica, both that's going to affect all of us, but also affect the continent directly as well. So it's important to maintain that really solution-focused mindset and think about the small steps that you can all take as individuals and that I can take as well to help preserve such a wonderful place. Just another political cartoon for all of you. I really, really like this one because it exhibits very well the first stage that you take as an individual to make that transformative stage, and it is denial. And it could be denial because you don't want to face the realities of the situation because it's too scary or too upsetting. But nevertheless, if we don't do something about it, it's gonna come back and haunt us. So here I've just put up just a few very key, simple examples of how you can make changes in your daily lifestyles. And I know that some of these are incredibly familiar to you, you know, reusing and recycling and things like that. But the reason why I've left them up anyway is to really reiterate the importance of not losing sight of those small, simple, and basic changes that you can make to your daily lifestyles that will really have a larger impact on an accumulative rate. So there are some that I particularly want to point out that perhaps you wouldn't have considered. So is anyone planning to visit Antarctica? Hope you are. Brilliant. Good. So it'll be particularly important for you then to really opt for year 2 approved tourism. So sustainable tourism in Antarctica naturally is going to be important, particularly as it already is the largest industry for the continent. We also have other aspects as well, so naturally reducing single-use plastic, but what a lot of people don't realise is that the UK favours clear and not coloured plastics in its recycling system, and that's because it just has more uses again. So if you do ever have the option to choose between clear or coloured, I really encourage you to choose clear. We also have product replacement as well. So I've got an example here, I don't know if you can all see, but that's my Chili's bottle there. And they're really, really great. I'm not going to do spew some brand ambassadorship, but they're fantastic. But it's about making those changes to reusable objects and reusable items, but also things that don't require packaging as well. So for example, shampoo bars instead of shampoo bottles and things like that. So if anyone is particularly interested in finding a bit more about specific things that you want to change and you don't really know what you can switch it out for, then please come to me afterwards and I'm happy to give some ideas. So, sounds rather cliche, but it is the truth. Anthropogenically sourced climate change is anthropogenically sourced. You know, we are causing it. And we have to be the change that we want to be, because if we don't make the changes, then these effects that I've mentioned and these threats might not be reversible. So it's really important that you just, honestly, just get out there and do it. Even if it's the most minor change to your lifestyle, just believe in yourself because it genuinely will make a difference. And then through that, we'll really be able to advocate ocean ambassadorship. Thank you.
Absolutely fantastic. Thank you very much. Your passion shows. Have you got any questions at all? Shall I start with one? I'd like to know from you personally whether Antarctica should be left as a complete pristine wilderness or not. I mean, it's a loaded question, but your own view. Should we all clear out and leave it alone?
I think it's quite a difficult question to answer because I think from my personal perspective, it would definitely be the best case scenario for the continent would be to leave it alone. But I feel like naturally that's the case with everything that we discover. Most of the time it's normally best if we leave it alone. But in terms of science, it has uncovered some things that are applicable globally. For example, the ice core data. And we wouldn't know perhaps the scale of our effects on the world without that data. I think it needs to be more tightly regulated in terms of its tourism in particular, because the numbers are growing every year. So I think the Antarctic Treaty needs to be, well, they need to crack the whip a lot harder, in my opinion, and find a good middle ground.
Thank you.
Tom?
Tom.
It's a slightly part technical, part politics question. Everybody in this room will probably be in the situation that they look at a lot of the stories around particularly sea level rise. A lot of the reports that came out, probably going back about 15 years now, that were subsequently found not to be true around how much the sea levels may rise. And this did the unfortunate job, whilst well intentioned, turning a lot of people off caring about a lot of this. The sea level rise question, I wonder if it's unhelpful. It sounds dramatic when you put it on your graphs, but it's whenever it's put in news and the BBC science correspondent comes and says in 2100, X, Y, and Z will be the case. Everybody's sitting in their living rooms thinking, I'm going to be alive in 2100. The more immediate research that I've seen recently and I've read is around particularly related to your graph on ocean currents. In this country, our weather is determined partly by ocean currents, which in part are determined by your references to the Antarctic water systems. Britain should be a lot colder than it is, based on where we are. We should have a climate similar to Norway. We don't have a very mild climate. Do you think that it would be better if, from a policy point of view, if people focused more on the impact that changes in ocean currents, and rather than focusing just on the sea level, okay, if people pushed the impact of the changing weather systems, people can perhaps relate to more clearly. Do you think that should be focused on more? The fact that very small changes in ocean currents, very small changes in the way the ocean behaves could result in quite dramatic changes in weather, and that would perhaps give people, ordinary people as well as governments, more of a kick in understanding it, doing something about it.
Yeah, absolutely. I completely agree. I think policy has a really poor way of representing other equally as large issues as sea level rise. Particularly with sea level rise, we're looking at, like you mentioned, a really, really long time scale. And it's really difficult for people to personalize themselves with that if, like you said, they're not going to be around. And I think that is one of the key problems that we face in changing, our normal behaviors and attitudes towards it, because we're not going to be there, so what does it matter? It's about kind of taking on that ownership and that responsibility and recognizing that we have all contributed, and therefore, we all have a responsibility to do something about it. I think in terms of ocean currents, it's perhaps a more complicated situation to elaborate across to the public accurately and in the right amount of detail. But I don't think that's why it's not been done. I think it's not been done because politicians don't prioritize it, quite frankly. But I think it would make a big difference, because that way people are able to relate a lot more to their weather, because I'm sure you all care about how much sun we're going to get every year and how much rain and so on and so forth. I know I do. So yeah, I think it's definitely something that needs to be worked towards, but I think it would take quite a lot of time to be able to translate that science into knowledge that we can easily communicate to the public, so that everyone can really clearly gain an understanding of the effects that changing ocean currents in the Antarctic will have on us. Yes, in the back. Hello.
Yes, the magnetic poles are weakening at the moment and slightly moving off the same positions. Of course, if you go back to geological time, they've done that down the millennia, and they've swapped north and south poles are swapped. Now we're in a position of weakening magnetic poles. Does that affect the weather pattern and the oceans?
So atmospheric and oceanic systems are a lot more interconnected than a lot of people think. So I believe that it definitely would have an impact on the weather that we experience, although I wouldn't be able to give you specifics as to the science behind that. But it's definitely something that I'm going to personally take away with and look into a lot more.
Yeah, because clearly that can't be human controlled.
No, of course not. No, this is true. And this is where it's important to differentiate the factors that are happening naturally, because actually, if we're speaking geologically as well, climate change is natural. Climates have naturally changed across thousands of years in the past, and we have the ice core records, for example, to back that up. However, the effects that we're having is anthropogenically forcing that climate change, with the emphasis on the word forcing, like we are creating this change in the climate. It's no longer natural. So I think it's a really excellent point. We've got to be able to differentiate between the natural changes like the magnetic poles and then the anthropogenic changes.
The oceans have been rising for the last 75,000 years.
Yeah.
Quite considerably. And as divers, of course, we know they dive on ancient sites, now submerged. So how much is actually changed in the last 100 years rather than a trend over 75,000 years?
Again, I wouldn't be able to tell you like specifically, for example, the sea level rise in various places. And that is partially due to the fact that the world is globular, it's not actually spherical. So you would have, for example, 3 to 4 meter sea level rise at one location and say no sea level rise in another. So it is quite difficult to elaborate on. So yeah, I'm really sorry I can't answer your question. Does anyone else have a question?
Yeah, the recent breakdown of the polar vortex, that was sort of, somebody go back to that Dennis Quaid film of 20 years ago where suddenly the cold was sweeping down from the south and suddenly America had to move down to Mexico and all that sort of stuff. I mean, what was the cause of the breakdown of the polar vortex recently?
So a lot.
Oceanic, or was that more to do with us?
So a lot of people say that it's a combination of both.
Okay.
So I think what scientists are struggling with nowadays is to pinpoint the changes as to whether they're anthropogenically forced or whether they're naturally occurring. And it's quite an ongoing struggle because, like I mentioned, we have climate change, and features like the polar vortex will change naturally. They have their own natural oscillations, but it's difficult now that our effects are becoming so much more prominent. How can we separate the change as to be caused by us or as to be caused by natural effects? So I can imagine that there's no clear consensus from science on whether it is human caused or not, but I can imagine that it's pretty feasible to assume that we have had some degree of effect. Yeah.
How do the ocean currents around Antarctica change between the seasons, so between summer and winter in that continent?
Yeah, so the currents themselves don't necessarily change, but for example, in those surface layers, if we're talking about in winter, inherently it is a lot windier, just due to the season. And as those winds move across those surface layers, they will enhance the current's velocity. But it's just like a normal seasonal variation. Other than that, it's just essentially maintains its constant characteristics all year round. Yeah.
You mentioned, some scientists have mentioned several times about reversing the trend. Is that something that's actually possible, or is it really a case of just limiting destruction? Are things, speaking from, say, ecosystems in a biological sense, is it reversible? Are things reversible from that sense if we eliminate or reduce carbon dioxide?
Yeah, it's a really good question. I personally think that the changes that we make will never be fully reversible. So changes that are as a consequence of our activities. But we never know. If we were to stop and then a natural climate change period came around, for example, I know we're talking about thousands of years here, but as an example, interglacial. That could then create the environment required for example, X species to then re-thrive. So, yeah, it's quite difficult. I personally don't think that they'll be reversible, but the point is it's important to not have the attitude that it's just never going to end, because then, what's the point? We're just essentially kissing goodbye to the planet that we live on. So, yeah, I hope that answers your question.
Just
an observation. To actually achieve that, you're pretty much telling 80% of the world's population that they have to remain in poverty and live at subsistence. They'll never experience a Western lifestyle with power, medicine, and everything else. So to stop the planet now and hold point 2, we have to tell 80% of the world's population, don't expect the lifestyle that you see on the TV that the West has developed over the last 200 years. Now, if you think a politician has got the backbone to stand up and say that, then he or she will be a very rare individual.
It's a very excellent point. It's actually something that my friend Simon and I were talking about over lunch for a few minutes.
I think we shouldn't end on a gloomy note, actually.
I agree.
Actually, I could take you down the road now, at this very minute, and one of the world's top scientists is actually growing coral in London. And a lot of wonderful things happening. It's down at the Horniman Museum, and I took you there at this minute. It would replicate in the area Singapore to the minute, to the moment. And in 360 days of the year, for 20 minutes, the coral was spawned sexually at the same time, almost to the minute, as Singapore and also the Great Barrier Reef. So we are doing fantastic things. And I heard an interesting thing, our filmer here, Simon, is also a student, and we talked about the Maldives. The last lecture I went to said within reason soon the Maldives will be smothered by ocean. And I think Simon said perhaps not if we grow the coral around it.
Very right.
So I think we should end tonight anyway, and say that some wonderful things happening.
That was wonderful. Thank you very much. And from my perspective, it was a beautifully balanced lecture, very professionally delivered, and so thought-provoking. So I congratulate you. And I think if everybody can just take away one little message and share it with somebody tomorrow morning, I think I'm very positive. I've got to start somewhere.
Well,
Thank you both very much. For those of you who are staying for supper, it's in the Seagrave room. So, and if anybody is interested in more of the sub-aqua lectures we put on, please do go to your profile on the website and tick sub-aqua, because then you will automatically get flyers and notices, hopefully, that you might otherwise miss out on. So, on that note, thank you.
Thank you.
Thank you.